Hey y'all, and welcome back. Today we're going to be talking about divisibility rules. Now, divisibility rules are rules that we can use to figure out very quickly if our dividend can be split up evenly by our divisor. If it will split up into a nice, neat number, it will follow one of our divisibility rules. Okay, so divisibility rules are mostly useful when we're trying to simplify down fractions. Let's see some examples. Here are our divisibility rules. We're going to worry this year just about the rules for 2, for 3, and for 5. If you're taking notes, I would go ahead and I would draw 2, 3, and 5, and then I would split up this space over here, so that way we have a space to write our rule and a space for us to give an example. So, let's look at 2. We can tell right away if a number is divisible by 2, that means if it will be able to be easily divided by 2, if the number is even. So we check if the number is even. If the number is even, it's divisible by 2. So let's look at some examples. If I look at the number 13, that doesn't work because 13 is not even. That means if I try to divide 13 by 2, I'm going to get some decimals or some fractions at the end. It's not going to work for me. But if I try the number 24, 24 is an even number. Because it's an even number, I know that when I divide 24 by 2, I'll get a nice, neat end. It won't have any decimals, it won't have any fractions, it'll be nice and neat. I'm going to give you one, and I want you to see, do you think it's going to be divisible by 2 or not divisible by 2? Let's try an easy one first. 34. I think 34 is going to be divisible by 2 because it's an even number. And sure enough, if I were to divide 32 by 2, I get 17. 17 is a nice, neat number. It doesn't have any decimals, it doesn't have any fractions, so I know that 34 was divisible by 2. Let's try a harder one now. Let's try a multi-digit one. Let's try 325. Without actually dividing, how can you tell if that's going to be divisible by 2? Well, we can tell because we check if the number is even. Here, this 5 is not an even number, so I know that 325 is not an even number, which means that 325 will not divide equally by 2. We'll end up with some decimals or some fractions. That's the only thing we have to remember for 2, if the number is even. Let's skip 3 for right now, and let's do 5, because 5 is the easiest one. 5, all we have to do is we check if the number ends in a 0 or a 5. If it ends in a 0 or a 5, it's going to be divisible by 5. So let's look at an example. I've got 123. Is that divisible by 5? It doesn't end in a 0 or a 5, so our answer is no. We can't divide that by 5 and get a nice, neat number. If we divide it by 5, we're going to end up with some decimals or some fractions. Let's try another one. What about 45? Do you think that's divisible by 5? I think so because it ends in a 0 or a 5. It ends in a 5, which means that this is divisible by 5. If I divide 45 by 5, I'm going to get 9, which is a nice, neat number. It's not a decimal, it's not a fraction. Let's try one more. 1,228. Do you think that's divisible by 5? Without doing any dividing, are you going to get a nice, neat number? Or are you going to have some extra stuff, like a remainder or decimals or fractions? I think we're going to get some extra stuff because it's not divisible by 5. I know that because it doesn't follow my rule. It doesn't have a 0 or a 5. Because it doesn't have a 0 or a 5, I know that is not a good choice for us. 1,228 is not divisible by 5. Now let's talk about 3. 3 is the most complicated of the numbers. Because 3, we don't just check the end number like we do for 2 and for 5. For 3, we have something complicated. What happens is we say the sum of the digits has to be divisible by 3. Whoa, that's complicated. This means that if I add up all of the numbers in a certain number, all of the digits, then if that number, if my new number is divisible by 3, the whole number is divisible by 3. Oof. Let's look at some examples, okay? So, what we said is the sum of the digits is divisible by 3. Let's look at some examples and then I'll give you one to put in for your example on your notes. So if I wanted to see the number 15, and I wanted to know if 15 is divisible by 3, if when I divide 15 by 3, I'm going to get a nice neat number. What I would do is I would take these two numbers, these two digits, and I would split them apart. Then I add them back together. 1 plus 5 is 6. If I can count by 3s to get to 6, then I know that 15 is divisible by 3. 3, 6, yep, since I stopped at 6, I know that 15 is divisible by 3. Let's try another one. This time let's try one where it won't work, where it doesn't work. Let's say I had the number 34, and I wanted to know if that's divisible by 3. I would take the 3 and the 4, and I would split those up. 3 plus 4, that gives me 7. If I count by 3s, can I get to 7? 3, 6, 9. No, it looks like I skipped over 7. Because I skipped over 7, I know that 34 is not divisible by 3. If I try to divide 34 by 3, I'm not going to get a nice, neat number. I'm going to end up with a fraction. So I know that that doesn't work. Now let's try one to put into your notes. Let's try one where I say I've got the number 24. Go ahead and try this by yourself. Pause the video and try this by yourself. Okay, 24. To see if this is divisible by 3, I'm going to split those numbers up. 2 plus the 4. 2 plus the 4 gives me 6. Can I get to 6 by counting by 3s? 3, 6. Yes, it looks like I can get to 6 by counting by 3s. That means that 24 is divisible by 3. If I divide 24 by 3, I'll get a nice, neat number. 24 divided by 3 gives us 8. I get a nice, neat number. All right, let's look at some numbers, and I want you to tell me what they are divisible by. So I'm going to make myself a chart here. And you look back at your chart for 2s, 3s, and 5s, and we're just going to put a check or an X on my chart to see if this number is divisible by 2s, 3s, or 5s. Let's start off with something easy. Let's start off with 45. The first thing that I do is I look and I see, is it even? Because that's my rule for 2. 45 ends in a 5, which means it's not divisible by 2, because it's not even. We're going to skip 3 for a second. We're going to go down to 5. Does it end in a 0 or a 5? Yeah, it ends in a 0 or a 5, so it's divisible by 5. If I divide 45 by 5, I'll get a nice, neat number. 45 divided by 5 gives us 9. Let's try one more. My 3 rule. My 3 rule says the sum of the digits is divisible by 3. So that means 4 plus 5, which gives us 9, is that number divisible by 3? Meaning, can I count by 3s to get to it? Let's try. 3, 6, 9. It looks like we can count by 3s to get to 9. That means that 45 is divisible by 3. 45 divided by 3 will give us a nice, neat number, because 45 divided by 3 gives us 15. Here we found our divisibility rules. This will help us a lot when we're trying to figure out if a number is prime or composite, and it also helps us when we're simplifying fractions, because we check through these divisibility rules to see if both fractions are divisible by any of these 3. It won't get all of our primes, but it'll get most of them. Let's try one more example, and then we'll be done for the day. So again, I'm going to write out my divisibility chart. I've got 2s, I've got 3s, and I've got 5s. And I'm going to check a bigger number this time. I'm going to check a number that's 1,243. 1,243. The first thing that I'm going to do is I'm going to see, okay, for 1,243, does it work for 2s? No, it's not even, so I know it's not divisible by 2. Does it work for 5s? Well, it doesn't end in a 0 or 5, so it's not divisible by 5s. Does it work for 3? 1 plus 2 plus 4 plus 3. 1 plus 2 is 3, plus the 4 is 7, plus the 3 is 10. Can I count by 3s to get to 10? 3, 6, 9, 12. I can't, so none of my divisibility rules work. Sometimes that'll be the case. Sometimes none of our rules will work. Let's try and see what would happen if I were to adjust this. If instead of having a 3 at the end, what if instead of having a 3, I had an 8? So I'm going to go ahead and I'm going to plug in, instead of a 3 over there, I'm going to plug in an 8. It's still just as easy. First, I notice that it's even, so it's going to be divisible by 2. It doesn't end in a 0 or 5, so it's not divisible by 5. Then to find out if it's divisible by 3, I add up all the numbers. 1 plus 2 plus 4 plus 8. If I add up 1 plus 2 plus 4 plus 8, I end up with 15. Let's count by 3s and see if I can get to 15. 3, 6, 9, 12, 15. It looks like I can get to 15. That means that yes, it is divisible by 3. Even without dividing it, we know that when we do divide it by 3, we'll get a nice, neat number. All right, I hope this helped, and I hope to see you again soon. Bye.